A warm welcome to all of you. Hope the year's off to a great start. I want to tell you a data story today, a story about how we changed analytics at Wattpad. As part of this story, I'll tell you what Wattpad is, what we do, then talk about Wattpad's data and where analytics fit in, what did analytics do and what worked, what did not work, and the journey we took to make analytics better. But first, a little about me and why you should listen to me. I've been in this data space for a while now. I've worked for small and mid-scale high-growth startups in different capacities. In my previous life, I was a systems engineer and I worked in the mobile space. Right now, I manage ML and data science at Wattpad. And I'm keen on taking data from just being a nice to have to a must-have. And I've been fortunate enough to be able to strategize around this idea and experiment in real-world scenarios, mostly through my work. At the end of this talk, I hope you have a better understanding of data in the wild, have some exposure to common situations, and hopefully I'll leave you with some ideas and a framework that you can then go apply to your own data situation. So let's start with where I work. I work for Wattpad. We are a multi-platform entertainment company. We are a leader in social storytelling, and our flagship app is Wattpad. Wattpad has content in multiple languages, and we have readers all over the world. Our community has around 90 million users, which includes 5 million writers. And all these users spend billions of minutes reading every month on the platform. We have more than 1 billion story parts published, so you can imagine there are a lot of stories, and around 1,500 of these have been published as books or have been adapted for TV and film. So operating at this scale means that we have a ton of data, a ton of event data that helps us understand our users, analyze their user actions, behaviors, and make a better product. And all these stories also mean that we have a massive collection of text data, and we can employ NLP, NLU to build ML models on all of this text data. So how's all of this data organized? I'll take you back to 2021 and describe how things were with data back then. So we had different functions in data, and one of them was data engineering. So the diagram here shows our stack, so how data was ingested, where was it stored, and so on. So data engineering was tasked with ingesting all of the data into our ecosystem. So what did this data look like? So we had data from our applications, so web or mobile. We had some third-party data sources, and we also had some internal databases. So all of this data made its way into a storage system, either through batch processing or through streams. So batch processing would be data that is being ingested at a regular cadence, whereas streaming could be near real-time data that is being ingested into your system. So once this was set up, the data would be stored in a data lake. So that would be all of the raw data. Or there could be some level of processing done on this raw data, and that data would then be stored in a warehouse. And the warehouse data would be used for different business cases. So that's how data engineering looked back then. We also had a team we call platform and infrastructure. Now, this team took care of setting up any cloud services or setting up any tools required for ML and analytics. So things like orchestration for data jobs, so a tool that will do that, or it could be a cataloging tool for all of our data. It could also be tools for ML-related activities. So it could be setting up a feature store or trying out different solutions for model management and then rolling out the best solution to all of the org. So all of this was in the purview of the platform and infrastructure team. And the third function was machine learning. And so we have several products in our platform, several data products in the platform. And one of them, a very important one for us, is our search and recommendation system. So what this does is it personalizes experience for our users. So users can do a number of things once they land on the homepage. They could look for stories, they could interact with other users, they could look for writers. So all of this is handled by our search and recommendation system. We also used ML for internal use cases. So this would be for either our product or business users. And this took us through a range of machine learning models. So we would employ classical ML modeling all the way to building NLP applications on neural nets. So all of this was being done back then, and we still do that. So for ML modeling, we would use data from the data lake. So all of the raw data in the data lake. We would build features on top of this data and then use those features downstream in model development. And last but not the least, analytics and our focus for today. So analytics was a customer-centric team. It was interfacing with business and product. The work that this team did could be categorized into either product analytics, so that would be feature analysis, experimentation, so hypothesis design, and then post-experiment analysis. Or it could also be used for business operations, so things like designing metrics or KPIs, or setting up alerting for different metrics. So all of this was being done by analytics. The data used here was mostly from the data warehouse. So raw data with some processing would be in the warehouse. And this is the data that analytics used to set up any reports, dashboards, or carry out any analysis. So diving deeper into analytics, the team followed a centralized engagement model. In a centralized model, there is this concept of a home and an away team. So different data analysts, or it could be data scientists, they are on the same team, in this case, the analytics team, but they spend a majority of their time partnering with an away team. In our case, it was a business or a product team. Now, this model allows for shared practices between all the analysts, between the scientists. It allows for a common knowledge base while supporting different functions or different teams. You'll notice that this model, in its ideal state, requires a one-to-one scaling. So as the number of product or business teams increase, the number of data analysts or scientists will also have to scale accordingly. So at the time, we were supporting 4 to 5 different teams. So the team size, the analytics team size required was not large, and this model worked well for us. Looking at the infrastructure, so like I described, we had our data lake. Some of that data, processed data, would get into the data warehouse. From the data warehouse, we would use it for 2 different use cases. One was the BI tool. So BI tool hooked to the data warehouse, and we would use this to set up any reports, dashboards, or queries for different consumers. Anything that the BI tool could not support, we would carry out that analysis outside of the tool, mostly using Python in notebooks. These notebooks would be versioned and tracked. And our consumers used both of these. So they would use the dashboards, reports, and queries set up using the BI tool. They would also use the artifacts from these notebooks. So both of these were used for generating insights and just tracking all recommendations by the consumers. Now, we had a centralized model, and I described the infrastructure we used. So with all of that, what did the team usually work on? Work was primarily informed by stakeholder needs. And you can think of stakeholder needs as an abstraction for business goals. So there are business goals. The stakeholders derive their own goals from these business goals, and then translate those into some data requirements and send it to the data teams. The analytics team had a trinity of tasks. One was ad hoc analytics. So these would be ad hoc requests, and an example would be get me data on a metric from this month, from this year, or get me a list of users who fulfill some criteria. The second one was experiment analysis. So here, data analysts or scientists would partner with product managers to design a hypothesis for an experiment, then design metrics to test this hypothesis. And once the experiment was complete, they would carry out post-experiment analysis. And the third kind was deep dive analytics. So this was analysis that usually spanned multiple days, took multiple considerations into account, and would be what you would generally call complex analysis. So now all of these are pretty normal to any analytics team. This is the kind of work an analytics team does, but their distribution is what truly gives an insight into how well data is set up to be utilized. So we decided to analyze this aspect. And when we did, the distribution looked something like this. As you can see in the first chart here, it is skewed towards ad hoc. So to give you some numbers, 70% of the team's time and work was towards ad hoc, 20% towards experiments. So this would be hypothesis design, post-experiment analysis, and so on. And only 10% was towards deep dives. Breaking down ad hoc further, what we realized was that most of the ad hoc work was first order analysis. So these are the when and what questions. So what happened and when did it happen? Only a small portion of the ad hoc was second order analysis. And so those are the why and the how questions, which are generally tougher questions and need more complex analysis. So what this implied was that most of analytics was simple and ad hoc, which meant that the team's primary function had become that of a service desk. Let me elaborate on what I mean by service desk. So most interactions with stakeholders were through tickets instead of being through a consistent, regular partnership. The impact of this was that there was lack of context. There was repetitive work, repetitive work because it was one-way communication. So the stakeholders did not always know what other stakeholders were creating tickets for. There was lack of context because most interactions were through tickets and not through face-to-face conversations or real conversations. And the team was underutilizing their expertise. So we had a smart bunch of people, but all they were doing was some simple analysis. So with this knowledge, we decided to diagnose the root cause for the skewed distribution. To get insights, we conducted user interviews. We engaged in conversations with stakeholders and data team members. And through these interviews, we built an understanding of what an ideal data partnership looks like. So what is our vision for this partnership? And what are some short and long-term requirements for this ideal partnership? One of our findings from the user interviews was that there was a disconnect between what the stakeholders asked compared to what they really desired. So they were interested in complex insights, but the asks reaching the team were simple. So to give you an example, a business ideally wanted data to help them plan in the long term, and carry out research on trends, predictions, forecasts. But the asks reaching the team were mostly focused on the immediate. So get me this data right now. I am not really sure how this data will help me 3 months down the line, but this is what I need today. And this insight was supported by data. So the skewed distribution that you saw earlier was exactly this. So the team was creating value, but the value was limited to what can be derived from simple techniques, which is obvious. There is only so much information you can extract from simple transformations or simple techniques. So what led to this? What led stakeholders to always ask for simple things from analytics? Our investigation led us to two reasons. One was stakeholder access to data. Stakeholders did not have an easy, reliable way to get the exact data, the exact metrics they needed. They had one of three options. One was to go through the analytics team. What that meant was they would have to follow the process set up by the team, and their request would be subject to the team's sprint timelines. The other option was to they could write their own SQL, but if that was the case, they needed to be comfortable with SQL. And they also had to be sure the data they were using was being used in the right manner. The third option was to make do with existing work or reports. But well, that's not really an option because you always have new requirements. So the last two options were impractical, and all the stakeholders had to go through the analytics team. The other area that was partly responsible for this skewed distribution was the quality of data. And I'm using quality here as a catch-all, so it could mean different things, but let's just say for this session that quality of data here means how good your business logic is, how good the transformations are, what about data integrity, if you have data standards set up. So all of that would be under quality of data. In our case, data testing was limited. So not all of the data, all of the tables had tests integrated. Business logic wasn't consistently applied. So a rule could be applied to a table, but that rule could look slightly different when applied to a different table. And these rules weren't documented. So it was harder to see what was applied to what table and the reasoning behind it. Now, all of this meant that the results obtained by two people who may have designed their queries slightly differently would reach different conclusions. So that wasn't ideal. And a follow-up to this would be what about trustworthiness? So both of these issues meant that the trust in data was not as high as desired. So after we completed the root cause analysis, which uncovered two problem areas, we set up some goals towards making data more integral and valuable to the business. Our goals were, one, to reorganize data in a way that increased its utility. And second, to improve access to reliable, trustworthy data via self-serves. Now, these goals are linked to each other in a virtuous manner. So let me explain. So once you have utilizable data, so this is data that is trustworthy, reliable, and has been modeled for business needs. So it has the right transformations and aggregations. Once this kind of data is available, it can be opened up to consumers, all consumers, who can then use this data to produce consistent, reliable results. And this in turn reduces their dependency on a team like analytics. Now, what that means, the team now has more free time and they can use that time to engage in high value work. So that's how all these goals are related. So now we had the root cause, we had the goals. Our next step was to figure out how we would accomplish our goals. We decided to do so via One, a shift in culture. So going from stakeholders depending on analytics for their day-to-day to being self-reliant. Second, by building a data backend and a front end that would support such a shift. Now, this would comprise of three pillars for us. So the first one would be design and implement data models in the backend, along with testing. Then set up a new function, a new data function that's responsible for all of this work, which is data modeling. And have a front end that's able to utilize these data models and enable self-serve analytics to users. As you would have imagined, the second function was analytics engineering. So we had a solution. We knew what was to be done. The next step was to start actioning on it. In the interim, though, we had to make things better and free up some of the team's time so they could start to work on the solution. To achieve this, we looked at two aspects. One was a process improvement. So what could be done better in terms of cycle time and reduce inefficiencies. So we iterated on the processes that were being followed for ad hoc. We also brought in closer alignment of ad hoc with business priorities. So not everything is a priority, and we looked at prioritizing ad hoc in a way that prioritizes the business goals. So as desired, these measures led to some freed up time for the team, which we then utilized towards design and implementation of this new solution. And since business priorities were still being served, the impact to stakeholders was somewhat contained. We set up this roadmap to implement our solution. The first step was to carry out POCs of commercial tools. We researched a number of tools to see how they did against our wish list. After we had shortlisted some tools, we implemented some test metrics and dashboards using these tools. And this step ended with us deciding on what the backend framework and what the dashboarding tool would look like. Since this framework and the tool, both of these were new to us, we set up some time to train ourselves on best practices and some technical details. We also assessed our hiring needs, and this resulted in hiring of analytics engineers. After this, the next step was to plan the migration, that is, plan the migration from the old setup to the new framework and tooling. We set up a roadmap, and when we did that, we took business priorities and data quality into consideration. And based on that, designed a migration roadmap. As the migration progressed, we started training stakeholders on using the new tool. And after a good number of stakeholders could start using the new tool, we iterated on our engagement model with the stakeholders. Because the nature of work had shifted, many of their needs were being met through the new tool, so we had to redefine our engagement model. And the last step in this roadmap was a deprecation of our legacy system. So we did not need it any longer. So we had to plan on deprecation of the system, and then also look into any fallout and account for anything that would go bad because of this deprecation. So with all that I talked about, where are we today? In terms of our data organization, we now have a new function. We call this business intelligence. Now, this function does data modeling, data transformations, testing, and self-serve setups. This team works very closely with analytics. The reason being that analytics is the team with a lot of domain and business knowledge. And this is critical when it comes to designing data models. So business intelligence closely collaborates with analytics to leverage all this domain knowledge and use that in the data models. So you could say that the two teams co-own the data models. As for the stack, we have a new layer. We have a new BI layer, which is added on top of the data warehouse. Nothing else has changed. So the way we ingest data, where the data is stored, all of that is the same. But on top of the warehouse, there are two components now. So one component is the backend, which is responsible for all the modeling, transformations, and testing. And then there is the front end, which is our dashboarding tool, which reads all of this modeled data from the warehouse and then exposes that as self-serves to our consumers. The rest of the stack is untouched. Now, talking about impact of all that we did on business. So in 2022, we made steady progress on implementation of this new tool and migrating all dashboards, reports to this new BI tool. We also steadily increased the number of stakeholders who were onboarded onto this new way of analytics. And we are starting to see the impact of all these changes that we made. We have seen the number of ad hoc requests have gone down. So that means the analytics team is spending lesser and lesser time on ad hoc, and that time is being used for more and more high value work. There is greater visibility into data issues. So our data quality is getting better. There is also, we are also able to support a large number of business users, and these users are able to use our data reliably. And because the backend is robust, it's easy to scale the number of users. So it doesn't matter how many users we add, they will all see consistent results, which is what we always wanted. So you can see how analytics went from being a service desk to more of a thought partner. It has gone through all these shifts and changes. That's the reason I call this evolution of analytics. So with that, I'll end my talk. I hope this was useful. But if there is anything you would like to discuss further, please get in touch with me or post your questions in the chat. Enjoy the rest of the summit. Thank you.